We would like to present to you a universal setup for hands-on labs with the electric motor drive, electric machine, and electronic transformers. Mechanical part of the setup consists of 3 machines: a DC machine, an asynchronous engine, and a synchronous engine. All 3 electric machines can be operated both in the engine mode and in power generator mode. Whenever one machine operates as an engine, its complementary machine will be operating in a generator mode, loading the engine. With this approach, we are able to measure all static and dynamic characteristics for each machine for both operational modes. Electric circuits which provide operation of the engines are installed in the body frame of the setup. Work of the circuits is controlled by National Instruments hardware running a code written in the LabVIEW graphical programming language. All the measurements and operation control of the laboratory facility is implemented with the use of modular PXI platform of National Instruments, a reliable and high-performance basis for creation of multifunctional automated measurement and control systems. The setup is activated by turning the key and pressing the start button on the body frame. Then software for the hands-on lab should be launched. Before starting to work on the actual lab, the student should sign in by entering his name, grade, and major into the registration form. After logging in, the student will get into the main menu of the program. Hands-on labs which are listed in the menu can be selected by double-clicking on their names. This will bring up the main screen dedicated to that particular lab. The screen for each lab contains a diagram picturing particular circuit connection for the machines with valves and regulators which can be controlled by the mouse. As an example, let us run the hands-on lab titled Study of Mechanical Characteristics of a Separate Excitation DC Motor. While doing the lab, the student can operate the valves on the circuit with a mouse click and change the voltage and load by dragging the sliders, thus imitating different operational modes of the engine. Detailed instructions in the lower right part of the screen describe step by step how to do the lab, giving appropriate commands. A table is present in the left part of the screen. When the student clicks on the measure button, the data obtained from the sensor is entered into this table. This data is also graphed on the charts which are drawn in the lower part of the screen. All the required data are also represented on analog and digital indicators in the upper part of the screen. To start the lab, click the Start button in the upper left corner. This will make active all the valves that are present on the circuit diagram. By clicking on these valves sequentially, in accordance with the instructions in the lower right corner, we will start up the engine. Then, by changing the rotary momentum with the left slider and the load with the right slider, we set the system into a certain operating mode. The loading device in this lab is an induction motor connected to a frequency inverter. By controlling the right slider, we change the output frequency of the inverter, thus changing its resistive torque, which is contrary to the rotary momentum of the main engine. We need to wait for some time until transient processes are over and until a constant revolution speed is established. Then click the Measure button to enter the current values of measured parameters into the table. An appropriate point would appear on the chart immediately. The chart can be zoomed and scaled by a mouse click. Then we change rotation and resistance torques, thus taking a few more points as required for building the chart of mechanical characteristics of the drive. Having finished with this, we shall click the Stop and New Session buttons. Upon making appropriate changes in the circuit in accordance with the instructions in lower right corner, we are getting into the next stage of the lab. Any measured values can be stored by clicking the Save button. All new data sets in the table will be marked with a different color. Thus, in this lab, we measure the mechanical characteristics of electric machines with different or mature resistances by changing excitation and dynamic loading currents. In a similar way, the majority of classical experiments dedicated to study of electric engines, electric machines, and transformers can be demonstrated with this setup, thus improving significantly visual comprehension and effectiveness of the labs.